Awesome. Let's see how we did. Well, if I was going to find the area, we can find the area by adding up this rectangle and this rectangle, or taking the large rectangle and subtracting off this amount. Since we've been doing the subtraction method, let's do that again. So taking a look at the large, I'll label this area because that's what we're looking for. We're going to have the large rectangle minus the smaller rectangle. And we have a 14 by 7x. And then this small rectangle is a 3x by, well, I'm not sure about what this length is from here to here, but I know the total length is 14, which means this amount is 5 less than 14. What's 5 less than 14? 9. So it's a 3x by 9. Remember, area is base times height, so this is going to be 7x times 14 minus 3x times 9. 7x times 14 is the same thing as 14 times 7 number of x's. 14 times 7 is 98. So you have 98 x's minus 3x times 9 is 9 times 3 number of x's, so 27 x's. And you have 98 x's and you take away 27 of them, you'll end up with 71 x's. They're like terms. So the area here is 71 x's square units because we weren't given a length measurement. So that's the answer for the area. Let's talk about the perimeter. Perimeter goes all the way around. Perimeter. When I'm talking about the perimeter of a shape, I usually like to circle where I start. So when I'm going around my shape, I don't double count that. So I like to label where I start. So when you're figuring out your perimeter and adding up all the sides, please label where you start. I'm going to start at 14. And I'm going to go this way. Plus this length, well, if the entire amount is 7x, and from here to here is 3x, the remaining length is 7x minus 3x, which is 4x. So plus 4x plus, from here to here, oh, we already said it was 9. Here to there is 3x, 5, 7x. Do I have to add 14? Oh, nope, I started there. So let's see if we can add some like terms. 14 is a like term with 9 and with 5. So I can think about this as 14 plus 9 plus 5, which gets me 28. And 4x, 3x, and another 7 x's gets you how many x's? Gets you 14 x's. And we like to put our variable term in front. So it's 4x plus 28, and again, it's a perimeter, so it's just one dimension units. Cool. Great job, you guys. Since we've done 7, let's move on to 8. Do you remember what the formula for the area of a trapezoid is? The area of a trapezoid is base 1 plus base 2 divided by 2 times the height. So in case we forgot what the area of a trapezoid is. So let's take a look at this trapezoid. How do I remember which ones are my bases versus just my legs of my trapezoid? The bases are always the sides that are, you're right, parallel. So I'm going to add up my bases, which is D and D plus 6. I'm going to take half of those and I'm going to have to multiply by the height. Remember, the height meets the base at a 90-degree angle, which means, and maybe you want to rotate your shape, so you can see these are the bases, so 12 must be our height. And I'll multiply by 12 at the end. So 1D plus another D gets you 2D. 2D plus 6 divided by 2, all times 12. Well, taking a look here, we have 2 2d plus 6 divided by 2 times 12. So we're taking half of 2d and half of 6. Well, half of 2d is 1d, and half of 6 is 3. I need to multiply by 12. Remember, you need to multiply all of that expression by 12, not just the 3. So I'm going to put parentheses around the whole thing. Again, what I did from here to here is I took half of 2d, which is 1d, and half of 6, which is 3, because that's what dividing by 2 means, taking half. Now I need to distribute the 12 to the d and to the 3 to get 12d plus 36. And this is my answer, so it's 12d plus 36 units squared, because this is an area. Great. Let's move on to number 10. Number 9 is very similar to number 7, and number 10 is similar, except now we have a funny compound shape. Let's make this into a triangle and a rectangle, and then find the area by adding up the area of this triangle plus the area of this rectangle. Okay, remember the area of a triangle is base times height divided by 2, and the area of a rectangle is base times height. Let's pause the video for 4 minutes while you finish 9 and 10. Please pause the video for 4 minutes while you finish number 9 and number 10. Awesome, let's take a look at how we did. Number 9. Number 9, I first started finding the perimeter, so I started here at 15x, and I started adding going around. So I have 15x plus 7 plus 3x plus 5 plus 7x plus 5 plus 5x plus 7. And this is where I started, so I don't double count. How did I find that this was 7? Well, that is congruent to this side over here, meaning they're the same. How did I find that this was 7x? Well, I know that this whole length is congruent to 15x, which means if this is 3x and this is 5x, the remainder part is 7x. And this again is equal to that part. So when you combined your like terms, you ended up with 30x plus 24 units. Remember, we always want to put the variable term first and then the number without a variable, which is called your, that's right, constant term. And the number in front of the variable is called your coefficient. Nice. Good job, you guys. When I was looking at the area of my irregular shape, I thought about finding the whole rectangle area and subtracting off this little 7x by 5 rectangle. And I'll show you what that looks like with the math. With the math, that looks like a 15x by 7 rectangle minus the 7x by 5. Area of a rectangle is base times height. So we end up with 105x minus 35x. So your final answer is 70x square units, or 70x units squared, because we're looking at an area. Nice job, you guys. Let's take a look at that last problem you had to do, which was number 10. Let's take a look at number 10. Number 10 says find the area of the figure below, and we had already broken this figure into a triangle and another rectangle. So when we looked at this triangle and this rectangle, we had to find some information about it. And I broke this rectangle up into a 9x by 4, which was given to me. And then to find the height and the base of my triangle, I knew that this was 5x and the whole thing was 9x, which means the remaining part had to be 4x. So the base of my triangle was 4x. Then to get the height of my triangle, which I knew the whole entire side length was 10, and this part of my rectangle was 4. That makes the remaining part 4 less than 10, which is 6. So that's how I found my triangle to have a height of 6 and a base of 4x. So then when I used my expressions for the area of a triangle, 6 times 4x divided by 2, base times height divided by 2, and base times height for my rectangle is 9x times 4. From there, 6 times 4x is 24x, still divided by 2, and 9x times 4 is 36x. half of 24x is 12x, and when I add those together, I get my final answer of 48x square units. Nice work. Okay, let's turn the page and do our last problem for this lesson. We have a bullseye shown to the right, and it's made of 2 concentric circles, meaning this one's not over to the side a little bit. This is 4.5 all the way around. The radius of the smaller circle is 4.5 inches, and the larger circle has a radius of 9. So from here to here is 9, and they broke it up into 4.5 and 4.5. We're going to use 3.14 to approximate pi in calculating the area of the different sized circles here. So taking a look, the smaller circle, which again, the smaller circle has a radius of 4.5. Area of a circle is, you're right, pi r squared. So we have pi times 4.5 being squared, because that's our radius, halfway across the circle. And 4.5 being squared is 20.25. Quick calculator work, and we're using 3.14 to approximate pi. Multiplying that in my calculator, I get approximately 63.585, which that means if we are going to be, well, I guess we're not going to be rounding, we're going to say this is approximately 63.585 square inches, or inches squared. So that's for the smaller circle. Now let's take a look at the larger circle. So remember, our larger circle has a radius of 9. Area, it's still a circle, so it's pi r squared. So that means this is approximately 3.14 times 9 being squared. Do you guys remember what 9 squared is? That's right, it's 81. And 81 times 3.14 is about 254.34. So we know that this area is about 254.34 square inches. And now they want to know the space between the smaller circle and the larger circle, which would be the outer ring. So all of this area here. So if I want to know that, we're going to take the larger circle, which had a radius of 9, and we're going to subtract the smaller circle, which had a radius of 4.5. We already calculated those numbers, so we have 254.34 minus 63.585. And when you do that, we get about 190.755 square inches. Nice that they were all in the same units. Really cool. So 2 last questions. Assuming the dart hits a target somewhere, what's the probability of hitting the smaller circle's area? So this is the small circle over the total area. Remember, the total area is the large circle. So the small circle area was 63.585, and we're dividing it by the total area, which was 254.34. When I grab my calculator and I put that in, we get, that's right, 0.25. So we can say, using probability notation, capital P, probability of hit small circle is, would it be 0.25, or we want to write that as a percent? So we're going to move the decimal over twice and say it's 25%. 1 out of 4 times, you'll be able to hit the small circle. That's excellent. So what's the probability of hitting the outer ring? Well, we can think about probability. If you're not hitting the small ring, you're hitting the outer ring. If we're landing in this area, the probability of landing in the area is 1. 100% minus 25% is 75%. Probability of hit outer ring is equal to 75%. Or we could look at the area of the outer circle over the area of the total. And again, that's going to get us 190.755 that we calculated in part C, divided by 2